Hello friends, welcome back my YouTube channel MS Maths. In this video, I will explain you groups of order from 1 to 15. So I will discuss all the possible groups from 1 to 15 whose order is 1 to 15. Okay, so this is part 10 of this group theory. I will highly recommend you that first go and watch my previous 9 videos so that you will get the concept, because this is a summarized video for all those particular videos that I explain the concept, I use the concept, then I am going to use that concept in this video. So first please watch those videos and then now come to this video. Okay, now in this video I will start from one or from the order of group from 1 to 15, and I will describe the properties and I will discuss different categories of the group. So I will discuss order by order from 1. I will take the examples, all the possible example of order 1, and then cyclic group, is it a cyclic or not, is it a abelian or not, and some remark that I'm also going to use here. But before proceeding forward, I want to explain something here. What are the things here? What is the order of group? Okay, so order of group is nothing but number of elements in a group. Okay, so number of elements in a group is nothing but order of this. What is cyclic or what is abelian group? If you have any group, like this which is satisfying A star B, which is satisfying A star B and B star A. What is cyclic group? Cyclic group is something like that. If you have order of G is n, then there exists at least one element whose order is also n. That is what the cyclic. And if any of the group of order P into Q, where P and Q are primes, okay, these both are primes, then if P divides Q minus 1, then it is maybe cyclic. If P does not divide Q minus 1, then non-cyclic. Okay, if one more concept is there, if group of order P into Q where P less than Q and these are the primes, and this is an abelian group. If it is abelian group, then if P does not divide Q minus 1, then it is a cyclic. If P divides Q minus 1, then non-cyclic. This is the thing. One more concept is there. If P is prime number, then order of G is equals to prime, always cyclic. Order of G is P square, then always abelian, or order of G is prime cube, then non-abelian. Okay, there are one more concepts are there that I want to explain you. If a group G is abelian, then it is cyclic, may or may not. But if G is not abelian, then it implies not cyclic, 100% satisfied. Okay, one more thing. If G is cyclic, if G is cyclic, then it implies it is an abelian group, 100%. Okay, here I can say 50-50, yes or no. Okay, it is not necessary, but to be cyclic it should be abelian. So this is something called necessary condition. Okay, this is called necessary condition. If a group is cyclic group, then yes, it must be a abelian group. But if it's not a abelian group, then it can't be cyclic group. If it is abelian group, then may or may not be cyclic. Okay, हो भी सकता है और नहीं भी हो सकता. That's what the simple case. Next, there are certain more properties are there. If yes, using these properties. Okay, yeah, one more concept is there. If you are taking any of the group like this, Zm cross Zn is cyclic if and only if the GCD of M and N is going to be 1. Okay, if GCD is 1, then you will say these are both cyclic group that I explained, that I am going to use in this case. Okay, now next we'll take examples. Start with order 1. So starting from order 1, yes, one more thing. Every Zn group is always cyclic. So every Zn group under addition modulo is always cyclic. It means always abelian. Okay, now start with 1. So order 1 element, order 1 group. So order 1 group is something called Z1. Example of group Z1. Yes, it is a cyclic. It is abelian. Okay, smallest group. Smallest group of cyclic and abelian. Okay, so from here I can just write. Okay, one thing that I can take like this. Wait. So it needs only this much space. It also need only this much space. So I can write remark easily. Yes, so remark is what? Smallest cyclic and abelian. Okay, smallest cyclic and abelian group. Next, Z2. It is also cyclic, so abelian. Next, Z3. Z3 also cyclic and abelian. Z4, order 4 element, Z4 and K4. Okay, I can write the elements also. Z0, 0 and 1, 0, 1, 2, 0, 1, 2, and 3. Identity AB and AB. What about this? It is a cyclic abelian. It is not cyclic but abelian. So I can say this one is, for this one, it is smallest non-cyclic group. So K4 is smallest non-cyclic group. Okay, next, Z5. Okay, 0, 1, 2, 3, 4. This is cyclic abelian prime. The concept of prime you can say, or here you can also say concept of prime. Okay, so order of G is equals to 2. Here also prime number, so it is a cyclic group. Okay, so this result, probably this result will help you. So from here you can also see this is what order of group is equals to prime square. then abelian, but because of that it is a Zn, then it is cyclic group. Okay, next 6. So order 6 element, you can say Z6 always, or you can also write Z3 cross Z2 because GCD of 3 and 2 is a cyclic. Okay, so individually you can just write Z6, then Z3 cross Z2 because GCD of 3 and 2 is equals to 1. It is also cyclic and abelian, or you can just write like this. So I can write this in remark. So this will be Z3 cross Z2, and for this remark is GCD of 3 and 2 is 1, then it is cyclic. Okay, so next one is S3. So it is 3 factorial means 6. It is not cyclic, not abelian. Okay, set group of permutation. S3. Next, it is abelian also. Next, you can see, okay, from here you can also see S1, or you can say S1. Okay, here you can also say S2. Okay, 1 factorial, 2 factorial, but these are cyclic and abelian also. Cyclic and abelian. Okay, next, order 7. Simple, Z7, cyclic and abelian. Order 8, Z8 is cyclic, abelian. Next, Q8 is not cyclic, not abelian, prime cube, that is 2 power 3, non-abelian. Okay, order 8 element, or we can also see what, 1 second, yes, we can also say Z2 cross Z2 cross Z2. Because GCD is not 1, then it is not cyclic, but it is abelian. So GCD of 2, 2, 2 is not equals to 1, so that it is not cyclic, but it is abelian. D4, it has also order 2 into 4, that is 8. It is not cyclic, not abelian. You can say Z2 cross Z4, not cyclic but abelian. Same concept. GCD of 2 and 4 is also not 1. So it is non-cyclic group. Okay. So these are about Z8. So this is very, very important. Okay. Because there are so many, lots of examples are there. Next, order 9. What about order 9? Let's say for order 9, Z9 is abelian, cyclic and abelian. Okay, and again it is what, prime square, then abelian, one case from here, and cyclic also. But converse not true for that P. Okay, it is not like that every time a cyclic group is order P. Yeah, if order P, then it is a cyclic group. Next we can say Z3 cross Z3. Okay, not cyclic but abelian. Why? The GCD of 3 comma 3 is not equals to 1. So it is non-cyclic, but it is abelian. Next, order 10. Now, simplest case, Z10, cyclic. Okay. Next, order of group of 2 into 5 means P into Q. Okay, and now if P into Q and 2 divides 5 minus 1, 2 divides 5 minus 1, and it is a cyclic. Just see this case, we don't know it is abelian or not. If it is divide, then maybe cyclic. Yes, it is a cyclic. So order group, it is a cyclic. If it is cyclic, then it is abelian. Just see P into Q, and P divides Q minus 1. And one more group is here, that is D5. Okay, one more group that I can also define, that D5. So order of D5 is 2 into 5. It is not cyclic and not abelian. So it is a non-abelian group. Next, order 11. Order 11 is simple because it is a prime, because it is a Z11. Okay, Z11, because order of Z11 is 11, cyclic and abelian. So order of group is P, means prime, then it will be cyclic. Order 12. Z is 12, simplest case. Z12, cyclic, abelian. Next, Z6 into Z2. It's not cyclic but abelian. How? GCD of 6 and 2 not equals to 1. So non-cyclic but abelian. Non-cyclic but abelian. Abelian. Okay. Important. Next, A4. Okay, before going to this, S3 cross Z2. Okay, 6 into 2 is non-cyclic, non-abelian. Okay, one more thing is there, A4. What is the A4? Group of even permutation. 4 factorial divided by 2. So 24 divided by 2. 12. It is also non-cyclic, non-abelian. D6. D6 is 6 into 2. 12. It is also non-cyclic. Okay, non-abelian. Now 13. Order 13. Z13. Cyclic, abelian. Okay, P. 13 is P. That is the order of group is 13. So prime number. Always cyclic. Order 14. Z14. Cyclic. Okay. Another thing. D7. That is what? 7 into 2. 14. Not cyclic. Non-abelian. Okay. One thing is that 40 is 7 into 2. Or P is equals to 2. Q is equals to 7. And 2 divides 7 minus 1. Then it is what? Cyclic. Yes. 15. Order 15. So order 15 is what? Z15, cyclic, abelian. One more thing is that order of group is 3 into 5. So P into Q type. So P divides Q minus 1. So P does not divide Q minus 1. So P does not divide Q minus 1 means if P does not divide Q minus 1, then this may be cyclic. For this case may be cyclic, but now it is only. So if it is abelian, then it is cyclic for this. If it is not abelian, then it is not cyclic. Okay, one thing is that very, very important. It is cyclic if it is abelian. If it is not cyclic, if it is non-abelian. Very, very important. Okay, so these are a group of order from 1 to 15. How we can read all these group in a single slide. This is what order 1 to 15. So thanks for watching my video. Keep watching MS Maths. If you are understanding the concept, please like the video, share the video. Thank you. Bye bye.